All right, guys, what's going on? Hey, building off of our polynomial operations here, we did adding, we did subtracting, we multiplied with monomials, one term times one term. We multiplied binomials, a two term times a two term. Now we're going to build into it a little more with pretty much any type of polynomial by using this next method called the box method. We're going to start off kind of slow, and we're just going to work with a binomial times a binomial, and you're going to see how box method also works instead of FOIL. And then from there, we'll see how it is the only thing that works because FOIL won't work. So, learning objective for the day, we're talking about multiplying any polynomial with the box method. Taking a look at the box method, guys, it's literally called box method for a reason. We are going to set up a box, and then the columns and rows are going to match the number of terms that are inside your polynomials. What I like to do is I like to make the smaller term polynomial my rows. And in this case, it don't matter, but I'm just going to put the first ones in there. Then I make the second polynomial the top, the columns. Once I have my rows and columns set up, now I'm just multiplying. And I'm matching these boxes together. So to make this box happen, I'm thinking, okay, I'm multiplying here, and I'm multiplying this one here to make that box happen, right? So I'm thinking negative x times negative 6x. And just like multiplying our monomials, you multiply the coefficients together, and then you combine the same variables by adding those exponents. Negative 1 times negative 6 makes positive 6. X times x, that's x to the first power. X to the first power, that's invisible, right? So add those together, it makes x squared. Next, doing the same thing, I'm going to have negative 2 times negative x. Negative times negative makes positive. There's only one x, so I can keep it as 2x. Working the third one here, negative 6x times negative 3, I get 18. Negative 6 times negative 3, positive 18. And then there's 1x, so I keep it as x. The last box, I'm working negative 2 times negative 3, which makes positive 6. Matching those boxes together makes sense now? See what I'm cooking with here? Now that I have these boxes matched up, guys, all I have to do is combine my like terms. And the nice thing about the box method, especially if you have it set up in standard form, you should notice diagonals are the like terms. I have 6x squared, I have 2x and 18x, and then I have the constant there with 6. So I can combine those. 6x squared, 18x plus 2x makes positive 20x. And then the last constant was a plus 6. Erase some of this real quick. See what we got going on? Setting up the boxes, combining our like terms, multiplying these binomials. Think about how it's similar and different with our FOIL method. First, still gets us that x squared term, right? Outer, inner, gets us the next two boxes, and then our last got us the constant. It's just set up a little bit differently, but you're doing the same thing, which really should be the case because it's the same question, it's the same operation we're trying to accomplish here, multiplication. Let me show one more. Setting up our box method, I have binomial times a binomial, so I need 2 rows and 2 columns. I like dropping the first one into the rows. I like dropping the second one into the columns, but it's important to have the rows be your smaller terms, your polynomial that has less terms, and the columns being the polynomial that has more terms. From here, we just multiply away. Negative 2x times negative 6x. Negative 6 times negative 2 makes positive 12. X times x makes x squared. Negative 6x times positive 6. Negative times positive makes negative. 6 times 6 makes 36. And I have 1x. Negative 2x times negative 2. Negative times negative makes positive. 2 times 2 makes 4. Okay, and then I have 1x. Negative 2 times positive 6. Negative times positive is a negative. 2 times 6 makes 12. Hit try. Okay, we're good so far. All we got to do is combine. I'm looking at my x squared. There's only the 12. I'm looking at my 4x and a negative 36. 4 minus 36 makes negative 32x. And then the last one is a minus 12. So now you have two methods of multiplying binomials together. You could use FOIL, first, outer, inner, last, or you could use the box method. I personally, like, FOIL was my thing growing up. That's the only thing they taught us was FOIL. Box method is way more applicable to any polynomial. So if I'm trying to like remember something when it comes to math, this is what I should remember. Because I could use it for any multiplication problem at all. In fact, let me show you that by going to the second level of what we're working on, level 2. And the reason it's like this is because, take a look, it's not just a binomial times a binomial anymore. You have 4 terms here times something with only 2. So let's set up our box. I want the rows to be the smaller, so I have 2 there. Okay, let's go 2 rows. 2, right? 1, 2, 3, 4, so I want 4 columns. And now I'm dragging and dropping. I'm moving these polynomials into their right spot. I want 5x to go here and the 2 to go there. This polynomial down on the side here. Now on top, I have this polynomial stepping down. Once I have my box set up, I'm multiplying the same way I did before. It's just that I have a few more boxes to fill, right? 5x times negative 5x to the third. Okay, that's negative 25x to the fourth. 5x times negative 5x squared. Again, negative 25. This time x to the third. 5x times 5x. Okay, 25x squared. Oh, I like the 25, huh? 5x times negative 4. Negative 20x. Negative 5x to the third times 2. Negative 10x to the third. Negative 5x squared times 2. Okay, negative 10x squared. 5x times 2x. Oh, I got positive 10x. Negative 4 times 2. I got negative 8. And now we're trying to combine our like terms. Think back to when it was just a binomial, guys. We had our fourth power, or our second power, and then we had just x by itself, right? Well, now we have more. But notice it's still following our diagonals. If we have it set up in standard form, you should notice this pattern. And it's just going to set up with your diagonals all the way through. Constant there at the end. So we could combine those like terms. My only x to the fourth, we're going to keep negative 25 x to the fourth. My x to the third powers, we got to combine. Negative 25 plus negative 10 makes negative 35 x to the third. Positive 25 and a negative 10 makes positive 15 x squared. A negative 20 and a positive 10 makes negative 10x. And then last but not least, our constant gets us the negative 8. Sheesh, combining all those like terms, huh? There we go. Look how they set up the box versus how we did. Does it matter? No. I'm telling you, this is my preference. I like the longer boxes than the taller ones. You know what I mean? To me, it's easier to see what to combine like that. But as you can see here, it doesn't matter. Let me know if you have any questions about this stuff, guys. Good luck. We'll do our best.